I'd like to give you some ideas of what I would use this to train for. And one of them, of course, is the basic refrigeration cycle. So we're going to start here at the compressor, and you would have the student walk through it and explain the refrigeration cycle, the condition of the refrigerant as it goes through the system. So here we have our high pressure superheated gas. It comes out of the compressor. It goes through our vibration eliminator line, goes into our oil separator. It leaves oil separator. Now it does not go up this line yet. It's going to stop at these two valves. We'll talk about that in a minute. But we're going to head them over here this direction. So we're still coming out as a high pressure superheated gas. We're going to come down here. This valve here isolates the tube and shell condenser. I've got it closed. I've got it open to go to the tube and shell condenser here. So we go down through the tube and shell. We're going to reject the heat out of the refrigerant into the water. It's going to leave the tube and shell condenser as a subcooled refrigerant. Let's come down here. We enter into the liquid line filter dryer. We'll have a sight glass here. They can explain what a sight glass is, what its purpose is. Then we're going to come through here, and then it's going to tee off. The subcooled high pressure liquid is going to go to the left to the number 1 evaporator. And if we've got this valve open, it'll go to the right to number 2 evaporator. It'll go through the evaporators. Now, it's going to absorb the heat from the air. We're going to come back as a low pressure superheated gas. Here's our metering devices, and this is where we're going to change from a subcooled liquid refrigerant to the low pressure gas. It's going to enter into the evaporator. That's where it absorbs the heat. And this is where it comes back out. Both evaporators will join here, come back through this common suction to the compressor, go through this accumulator. We have diagrams of this accumulator, and you can explain how the accumulator works, what its function is, what its importance is for the system. And then we'll come back through the vibration line, come back to the compressor, and the cycle continues all the way through. So you can use this to teach the refrigeration cycle and the condition of the refrigerant as it goes through the cycle. This is one of the first lessons that I would use this to teach, is the basic refrigeration cycle, the condition of the refrigerant as it moves through the system, and explaining how the heat is absorbed and the heat is rejected. The second lesson I'd like to teach about is the EPR valve. Now we've got one EPR valve per evaporator coil. But an EPR valve, remember, comes into play whenever it is used to keep up the pressure in the refrigerator coil, and it allows the freezer coil to get pulled all the way down to a lower saturation temperature. And that way we can control 2 different temperature evaporators with one compressor system. So we can teach about the EPR valve and its function. And while you're here, you can also talk about hot gas defrost by using the discharge bypass valve, and explain how solenoid valves work as well. So within this area here, you can discuss EPR valves, the discharge bypass valve, liquid line solenoid valves, and hot gas defrost. Lesson number 3 would be to explain the thermostatic expansion valve. Now here you have an opportunity to talk about the different types of thermostatic expansion valves, external bypass versus non-external bypass, and the reason you would have one. Also, you can use this to teach how to measure subcooling, how to troubleshoot superheat. You can adjust the expansion valve. Here we have an inlet screen. We can discuss why we have that and the purposes of it. And you can take the sensing bulb and loosen it and show how to troubleshoot, as we always know, a loose sensing bulb, and explain how we need a mechanical strap, not 10 pounds of duct tape and 5 electrical straps, right? And with that, you can teach a full course on TXVs. Now the fourth lesson is going to be on the water side of this system. So remember, we have a coax coil here, we have a tube and shell here. With these valves, you can route the water in either direction, but don't forget, you also need to reroute the discharge gas to whichever coil you're using. Here we also have a relief valve on the tube and shell. So we can discuss the importance of the proper water flow through these tube and shell or through the coaxial coil, and how to adjust a water regulating valve. Then you can set this up with low water flow and show how it affects the head pressure. One of the things I like to do is, before I do that, is ask the students what would happen if we had low water flow. Let them answer it and then explain their answer, and then you produce a low water flow situation, see what happens and see who was right, who was wrong, and explain how the difference is there. So here we've got the water side of the unit, low water flow, and then from there you can take them over to the cooling tower and explain how that cooling tower works and what would happen if it wasn't functioning right as well. And you can incorporate the centrifugal pump. So the entire water system can be taught in multiple sections or as one big overview. The fifth lesson I would teach would be on the electrical side of this system. So here we have our hard start kit, and in here we have our relay and start capacitor. You could remove a wire, so disable it and let them troubleshoot it from there. You can also always swap out a good component with a failed one, because you know we keep boxes of those around, right? So they could also go in and measure the start capacitor, teach them how to measure it, teach them how to troubleshoot a start relay. Then we have our compressor itself. You can go through the wiring of the compressor. We have our defrost time clock, go through how to wire that up. This is a working, active defrost time clock, so you can show them how to set it. You can pull all the wires off, have them rewire it. And then each evaporator coil has its own electric circuit. And on the freezer side, we do have electric heaters, which you can teach them how to check voltage to that, how to ohm out those heaters. We have the DFT control, and also we have the hot gas bypass. But here we've got a full electrical side that you can teach. You can break it in multiple modules or teach it in one overview. In summary for this, we've got a water side, we've got an air side, we've got the electrical side of it, we have the refrigerant side of it, and within each of those sections, we have multiple lessons that we could teach all together with this one unit, the TU-155.